All right, this is a video that will go through all the answers in the review for Module 2, the mid-module review for Mr. Lewis and Ms. Stanoff's classes. I'll go through each question, kind of talk through how I understand these questions, how I would do them, and hopefully that helps you prepare for the exam coming up. Okay, so first we're asked to dilate the segment centered at the point 1, -4 with a scale factor of 4/3. Now, the first place I start with that is by figuring out where the center of dilation is. Now, the origin is right here, and so the 0.14 is I go right 1, down 4, and this point right here is the center of the dilation. Okay, so one way that I like to dilate that is first to figure out from the center of dilation to the point I'm dilating, in this case I'll first do A, how far left and right, how far up and down I'm going. So I'm first going to go left a little bit. I'm going to go left 1, 2, 3 spaces, and you count the spaces, not the dots. Okay, so 1, 2, 3 spaces, and then I go up a little bit. I go up 1, 2, 3, 4, 5, 6, 7, 8, 9. I go up 9. Now, I'm next going to have to dilate that by a scale factor of 4/3, which is a fraction. Okay, so I'm going to do this pattern, this left 3 up 9 pattern. I'm going to do that a scale factor number of times doesn't work very well when my scale factor is a fraction. Okay, so you're kind of left with the method of I'm going to multiply both numbers, the 9 and the 3, by the scale factor of 4/3. Okay, now there's kind of two ways to think about this. First of all, you can just multiply like you multiply fractions. So if I think about 3 times 4/3 and think about this is 3/1, you could multiply fractions by multiplying the numerators together. And so 3 times 4 is 12. And the denominators together, 1 times 3 is 3. And then simplify and you get 4. Okay. The other way I like to think it through is that if 1/3, so I can think about 1/3 of 3, if I have 3 things, 1/3 of those 3 things is 1 thing. And if I have 4 of those thirds or 4 ones, then I have 4 things. So I'm going left 4. Either way, you get 4. Okay. If all else fails, then grab your calculator and do 3 times open parenthesis 4 divided by 3 close parenthesis enter, and you get 4. Okay, somehow multiply 3 times 4/3. Okay, next for 9 we multiply 9 times 4/3, and the way I think about it is 1/3 of 9 is 3. If I have 4 of those thirds or 4 3s, then I get 12. Okay, but we're multiplying those numbers by 4/3, and so from the center, I'm going to go left 4, 1, 2, 3, 4, and then up 12. That's 9, 10, 11, 12. This is A prime. Okay, now for the point B, I do the exact same thing. So from the center, I'm going to go right 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. I'm going to go right 6, and then I'm going to go up 3, and 4/3 times 6, well, 1/3 of 6 is 2. If I have 4 of those, then I have 8. Okay, and then finally 3 times 4/3 is, well, 1/3 of 3 is 1, and so 4 of those is 4. Okay, and again, if you're not really following kind of how I do fractions, you could just multiply 6 times 4/3 in your calculator. If you're at home with your cell phone or some other non-graphing calculator, then it might be easiest for you to do 4 divided by 3 enter times whatever number you have in the pre-image. Okay, but here we have 8 and 4. So if I go from the center of the dilation, if I go right 8 and then I go up 4, I'm right here at B prime. If I connect the dots, then I have the image of my dilation. Now, you can't see it on this screen because it's down below, but the first question being asked is what is the slope of segment AB. Okay, the slope of segment AB. Now, let me just remind you, I've had lots of these discussions in the last couple of days, is that slope is the measure of how steep a line is. We did this quite a bit last year in Algebra 1, at least I hope you did. It's a measure of how steep a line is, okay? A slope of 0 is horizontal, flat. It looks like this. Where's a good place to write it? Here. The slope of 0. If it's a slope that's this, it's positive, meaning left to right it's going up, or this is negative because left to right it's going down. Okay, this one is going down because it's sloped down. Now, the way you could use the slope formula, I like to kind of think about it as a rise and a run. Kind of erase this just so I have some more space to talk about slope. So the way I think about slope is I'm going from the left point to the right point. Okay, and I, for some reason, like to go up or down first. So I'm going to go from A to B. There's a direction to slope. I'm going to go down to there, right? So I'm horizontal with B, and then I'm going to go right over to B, right? There's a direction to slope. Now, from A going down, that is in the Y direction, but in the Y direction, down is negative. So I'm going negative 1, 2, 3, 4, 5, 6. I'm going down 6, which is a rise of negative 6. And then I'm running right, which is in the positive x direction, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm running a positive 9 in the x direction. So the slope of segment AB is equal to the rise over the run, which is negative 6 divided by 9, which simplifies because both of those numbers go into the number 3, or 3 goes into both of these numbers, and so it simplifies to be negative 2/3. Okay? The next question down below is the slope of A prime B prime. So the exact same thing as before. This one, even though I like to go down, I'm going to go above the line just so I can write it. From A prime to B prime, I think going left to right. I'm going to go this direction. Let's see here. It was down there. So here, I'm going in the positive x direction. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Count the spaces, not the dots. And then I'm going to go down to B prime. 1, 2, 3, 4, 5, 6, 7, 8. But I'm going down, which is in the negative y direction, 8, so it's negative 8. So the slope of A prime B prime is the rise over the run, which is negative 8 over 12, which is 4 goes into both 8 and 12, and so we get negative 2/3. Okay, and then the very last question, the last part on E says, are they parallel? And the answer is yes, because the slopes are the same. Or yes, because the slopes are equal. Okay, we talked about the fact that parallel lines have the same slope. I found the slope for both A, B, and A prime, B prime. They have the same slope, so therefore they are parallel. All right, number 2. Dilate the segment centered at 3, 0. Okay, so again, here's the origin. The point 3, 0 is here. That's the center of dilation. Point C, the point C, I'm going to go right 2. I'm then going to go up 4. Okay. Now the slope, the scale factor is 1/2, which is a little bit easier than 4/3. Half of 2 is 1. Half of 4 is 2. So from the center of dilation, I'm going to go right 1, up 2. And this point right here, C prime, is the image of point C. Now to find D, from the center, I'm going to go, I'm going to go left, how far? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Left 10, and then I'm going to go down 1, down 1. Half of 10 is 5. Half of 1 is 1/2. Now, we've never really had problems where the the amount going up or down, left or right is a fraction or a decimal, but that can happen. So from the center, I'm going to go left 5, 1, 2, 3, 4, 5, and then down a half, and I'll be right here at D prime. Connect the dots, okay, which is, so it looks parallel, which it is, but in number 2, we're looking at lengths, okay, the length of each number. So I prefer using the Pythagorean theorem method that I showed you maybe last week or so. But I think about this, this as a right triangle along the grid. Okay, this length is 1, 2, 3, 4, 5. Now for length, I'm looking, because lengths don't really have a sign. Like I don't care about direction like I did with slope. I'm just looking at the length. So that's 5. And this direction, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is 12. And so because the Pythagorean theorem is, let's just x squared is equal to, well, let's just say 5 squared plus 12 squared equals x squared. To derive this for you one more time, that means that x is equal to the square root of 5 squared plus 12 squared. Okay, that the length of x, the length of CD is equal to the square root of 5 squared plus 12 squared, which is the square root of 169, which happens to be a perfect square. Oh, how convenient, which is 13. Okay, the length of, this is, I think, part A, I think, is the length of CD, which is 13. Now, to find the length of CD, the exact same thing. I think about a right triangle. This length is 2.5. This length down here is 1, 2, 3, 4, 5, 6. 6. So this length right here is the square root of 6 squared plus 2.5 squared. 6 squared is 36. 2.5 squared is 6.25. And the square root of 42.25 is 6.5. Okay, that's part B. This was part A, yep. And then in C, actually, I guess it's not even lettered, never mind. And then the last question in part number 2 is what's the ratio of C prime D prime divided by, so C prime D prime divided by CD is equal to 6.5 divided by 13, which equals 1/2. The same exact same number as the scale factor. Okay. All right, moving along. Number 3, a little smaller here. Okay, number 3, in the coordinate plane, line L has a slope of 4/3 and passes through the point -1, 1. So if I go here, the origin's here, -1, +1 is the point right here. That's a point that this will go through. And the slope is 4/3. Well, that's a rise over a run. Rise over a run, measure of how steep the line is, which is 4/3. And so from this point right here, I'm going to rise 4, 1, 2, 3, 4, and run 3, 1, 2, 3. This is a point. Another point on my line. Rise 4, run 3. This is a point on my line. And I kind of just do that all the way around. Well, not all the way around, but through the graph. So this is line L, right? It goes through the point -1, +1, and has a slope of 4/3. Now, that's L. Yep. Line R is the result of dilating line L by a factor of 3. The scale factor is 3. And the center is 0, -1. So 0, -1 is right here. That's the center of the dilation. Okay, and it's kind of strange to be dilating a line that's infinitely long. Like we don't have endpoints to really work with. Okay, and this infinitely long line will now get 3 times longer somehow, and it still will be infinitely long. Okay, but the way we do this is by picking some points on line L and just dilating those points. In fact, really, we're dilating every single point on line L. So I'll just pick off a few that are convenient, like the point you started with, which is the point -1, +1. Okay, so if I pick that point, I'll call it, I don't know, point A. Call it point A. And from the center to A, I'm going left 1 and then up 2. And so if I do that 3 times, or a scale factor of 3, I'm going to go left 3 and up 6. And so from here, I'm going to go left 3, 1, 2, 3, up 1, 2, 3, 4, 5, 6. And this point right here, I'm going to call it A prime. Okay, now, unfortunately, with a scale factor of 3, this point right here goes off the graph. This point right here will go off the graph. So really, I only have this one point A prime to kind of base this off of, but we learned in number 1, and we learned, throughout our study of dilations, that when you dilate a line, you get a parallel line. And we also know that parallel lines have the same slope. So this will also have a slope of 4/3. So from this point, A prime, I will again go up 4 over 3, and this point right here, and I'll do it down here as well. 1, 2, 3, 1, 2, 3, 4, this point, and that point. Anyway, so I draw a line, and this is the point R. Now, to answer the question is, what is the slope and y-intercept of line R? Well, the slope of line R is the same as line L, so it's 4/3. And the y-intercept of line R is right here, where it crosses the y-axis, and the y-intercept is equal to the point 0, 9. Okay, number 4, triangle ABC is dilated from A, so here's a picture of a triangle, just a general triangle, ABC, is from center A. So this is the center of the dilation, point A is the center of the dilation by a factor not equal to 1, meaning it will get bigger or smaller. I, for some reason, like to think about dilations getting bigger. That's a little more natural for me, so I'll think about it just getting bigger. Okay, and the correspondence matters. So ABC corresponds with AKL, which means this point must be K and this point must be L. So now that I have that picture kind of there, I will answer the questions. AB and AK lie on the same line. Yep, that's true. The line containing BC is parallel to the line containing KL. Yep, that's also true. It's a property of dilations, is that they'll be parallel. Okay, C, angle ABC, which is right here, is congruent to angle ACB, this angle right here. Well, no, it looks kind of like it in my picture, but that doesn't have to be. That's be true if it's an isosceles triangle, but that is not always true. Angle ABC is congruent to angle AKL, and that would be true because they are corresponding angles. So that's true. Triangle ABC is similar to triangle AKL. Well, that would be true. I have angle A, and then I just talked about angle B and angle K. So yep, that's true. And they're not congruent because they're not the same size. So that's not true either. So AB and DE are both true. All right. Number 5, use the side splitter theorem to solve for x. Okay, the side splitter theorem is when a line is parallel to a third side, it'll divide the triangle proportionally, which means in letter A that I can look at 6 over 2 is going to be equal to 9 over x because the lines are parallel, and it will divide the triangle proportionally. And then I just cross multiply. So 2 times 9 is 18, and 6 times x is 6x. And then I divide both sides by 6, and x is equal to 3. All right, letter B does have some questions to it people struggle with. You still have the side splitter theorem. You still have x divided by 12 is equal to x plus 1 over 15. Now, this x plus 1 makes people a little bit suspicious or cautious. You really just do the exact same thing. So x times 15 is 15x equals 12 times x plus 1 is, I have to think about it as 12 times x plus 1. Okay, so multiplying. If I write it like this, then most students say, oh yeah, I got to do the distributive property, right? 12 times x and 12 times 1, both of them, not just one. Okay, a very, very common mistake is at the next step, you write 12x plus 1, which is not correct. I'm doing 12x times both the x and the 1. You can't leave the 1 out. It will feel left out. So we have 15x is equal to 12x plus 12. I will combine like terms by subtracting 12x from both sides. And I get 3x is equal to 12. And I'll divide both sides by 3, and x is equal to 4. Okay. Last but not least is C. Again, the side splitter theorem means I can do 8 over 7 is equal to 16 over 2x. Okay, again, that 2x is a bit different, but we treat it the exact same way. So 7 times 16, I don't know that one off the top of my head. 7 times 16 is the number 112. 8 times 2x is, well, 8 times 2 is 16. So 8 times 2x is 16x. I divide both sides by 16. And I get x is equal to 7. Okay, some pretty straightforward side splitter theorem questions. Okay, number 6, are the following figures similar? If so, what are the similarity transformations that map one onto the other? Write out and graph the sequence of similarity transformations and be precise. If not, then why not? Well, just looking at this, it looks like more than a dilation happened, right? So I can't just dilate it, it will look different. So if I look at it, I notice that this one kind of is pointing down, like it's pointing down, kind of like how this one's pointing down, right? So by first glance, it looks like it's a reflection, right? So A is going to correspond with N, and then F is going to correspond with C, and O to U. Sorry, no, U to T. So that's how it corresponds. So it looks like it's going to be a reflection, and then a dilation is how I would think of it. But first, I'm going to check the ratios of the sides. So keeping in mind the orientation of it flipping or reflecting, I can look at this right here and corresponds to this over here. So this length of 3 corresponds to this length right here. Do you see that? So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and I'm going to just do the big number over the small number. 9 divided by 3. Is that equal to, let's see here, this length right here, which is hard to see. This length right here in the small triangle is 1, and the corresponding length of the big triangle is 3. So big over small, or in this case, the left over right, is going to be 3 divided by 1. Now, those are the same. Check. If I look at this length right here, which corresponds, again, it's reflecting, corresponds to this length right here. This length is 2, and this length is 1, 2, 3, 4, 5, 6, the corresponding length. So big over small, left over right, is going to be 6 over 2, which again is equal to 3. So yes, those are proportional. And if I look at the length going down, I have 1, 2, 3. The length over here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Left over right is equals 9 over 3. Yep, those are proportional. And it's getting kind of small, but this length right here is 1. The corresponding length, again, it reflected, so it's right here, is 3. So yep, that's equal to 3 over 1. And last but not least, this length down right here, you see, is 2. That length is 2, and the corresponding length here is 1, 2, 3, 4, 5, 6. So I have 6 over 2, and yep, those are all equal to the number 3, which means the scale factor is 3. So based on all of that, I think that these two triangles are similar because all the sides are proportional with that, scale factor 3 that's coming in. If it's not going to be similar, then you'll have, usually multiple ratios that are kind of fall apart and not be the same. So in this case, they're all 3. And so that's the scale factor. So I next had to figure out the similarity transformations that will map one onto the other. Okay, again, as I said, I see a reflection and then a dilation. I like to do the dilation last, so that I don't have to deal with a translation. I can just do the reflection and then the dilation. So the first thing, first, I will reflect. Now, I like to reflect the small one, right, and go to the big one. That will give me my scale factor of 3, which is bigger than 1. Okay, but there's no reason why you couldn't reflect the big one and then do a scale factor of 1/3. Okay, but I'm going to go from small to big. So I'm going to reflect triangle. I'm going to call it FUN because this is fun. Okay, triangle FUN over, and the most logical thing is this line right here. Okay, which we could call the line x equals 0, but I think most of you call it the y-axis over the y-axis. And that's it. So I'm going to graph that because it says write out and graph. So if I graph this, then f is 1 away. So I go on the other side 1, and this is f prime. U is on the line, so it stays there. N is 1, 2, 3. So I go on the other side 1, 2, 3. And this is n prime. So I kind of just dotted line. This is where I'm at right now. Okay? Then I'm going to dilate triangle f prime u prime n prime, this, the image of the reflection, with a scale factor of r is equal to 3, right? 3 equals 3. From center, where's the center? So if I connect corresponding points, then they will all be, they will all intersect. What's the word? Concurrent, there's the word. They'll be concurrent at the point at the center. If I connect those right there, I get the origin 0, 0 from center 0, 0. Okay, so again, I'm going from f prime, u prime, n prime up to the triangle. Now, I'm not done. I want to write a little bit more, but I don't have space here. So what I write next, right below this in the space you have still on your page. I think there's space on the page on the review. Yeah, there's a little more space. So below this, write this. I'm going to erase this. So I just talked about the reflection and the dilation. I would next say this is a sequence of similarity transformations which again is rigid motions and dilations that map triangle FUN onto triangle. Now the correspondence matters. FUN corresponds with CTA. CTA. So triangle FUN is similar to triangle CTA. Boom. I'm done with number 6. Okay? Now, be aware that we practice some of these on worksheets. Some might be similar, some might not be similar, so be aware of that. There's going to be at least one of these on the test, maybe 2, but be aware of that. Okay? Number 7, in the xy coordinate plane, triangle ABC has vertices at A, which is at 1, -2, 1, -2. This is A. B is at 1.5. Again, we have some decimal coordinates, and that's fine. And C is at 2, 1. That's C. There we go. And triangle DEF has vertices at D, which is at 4, -3, and 4, 2, and 6, 3. Oh, I didn't label them. Let's see here. D, E, and F. And the question is, the triangles are similar, okay, because triangle DEF is the image of triangle ABC under dilation, okay. What is the center and scale factor? Well, the center, again, I get from connecting lines with the corresponding points, and it will be concurrent at the center. So if I just kind of start drawing lines, and I think more precise by thinking about from D to A, left 3 up 1, left 3 up 1, left 3 up 1. I guess I think of that because I can't pull out a ruler like you can. So if I start drawing my line, I'm right there. If I connect the points E to B, let me go F to C, so it's on whole numbers. So from here, I'm going left 1, 2, 3, 4, down 1, 2. I guess it's over 2, down, over 2, down 1, over 2, down 1, over 2, down 1, over 2, down 1, over 2, down 1. So it looks like it's right here, which looks like ding, 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 right here we have a winner. And the center is the point, let's see here, from the origin is here, -2, -1. And the scale factor is what? Let's see here. I can kind of get it from anywhere, but this length right here is 1, 2, 3, 4, 5. That's 5, and this is 1, 2.5, 2.5. Okay, now DEF is the image of ABC, right? So we started with the ABC and we got DEF. The scale factor is bigger than 1, and so we'll do image over pre-image, image over pre-image, or new over old, and get 5 over 2.5, which is a scale factor of 2. And there we go. Number 8. Whoops. Okay, number 8. Are the following triangles similar? If so, write a similarity statement. And the similarity statement is that triangle, letter, 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 is similar to triangle, triangle, letter, letter, letter. That's similarity statement. So make sure you're aware of that. With the similarity criteria, and we have 3 of them. Okay, we proved maybe none of them actually, but we have 3 of them. We have angle, angle, and we have side, angle, side, where the angles are congruent and the sides are proportional. And we have side, 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 where all 3 sides are proportional. Those are 3 similarity criteria that we could use. Okay, so in letter A, again, I have angle, angle, side, angle, side, or side, side, side to think about. Now, looking at A, I know lengths here and here in this triangle. So I have 2 lengths, which makes me think it's gonna be side, angle, side. Okay, because I don't have this length, so it can't be side, 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 and I only have, I don't have any angles right now that I see. So I don't think it's going to be angle, angle. Okay, if I look at the big triangle, this big triangle, again, I have 2 lengths. I really have this length right here, which is 10.5, and this length right here, which is 9. Okay, and I notice that these 2 triangles overlap at this angle right here, angle C. Okay, and that's the angle of our side, angle, side. So if they're similar, and I don't know if they are yet or not, it's going to be by side, angle, side. Okay, I have to check if the corresponding sides are proportional. Okay, and you can either use within figure or between figure ratios. I'm going to use the between figure ratios of 7 in the little triangle corresponds to 10.5. That this length right here corresponds to this big length right here, 10.5. And is that the same as 6 corresponding with 9? So is that the same as 6 over 9? At first glance, students say, well, no, because there's a decimal, but that may not really influence it. So you can either cross multiply, in which case you get 63 is equal to 63, which is a true statement. If it wasn't proportional, you wouldn't get equal numbers there. Or if you plug both in your calculator, you get 0.6 repeating for both of them. So yes, again, they are proportional. So the sides are proportional, the angles are congruent. The answer is yes, these are similar. So are they similar? Yes. Triangle, now similarity statement is triangle. I'm just going to call it BCD, right? BCD. And the correspondence matters is similar to triangle ACE. ACE. And then with the similarity criteria, by side, angle, side. Okay, in letter B, again, I will just use these up. I have angle, angle, side, angle, side, or side, side, side. I don't know anything about sides, and I have no way of getting things about sides, so it can't be either of these two. If they're similar, it's going to be by angle, angle. Now, I don't know if they're similar yet, but if they were, it'd be by angle, angle. And if I have two angles, I can find the third one because the three angles in a triangle add to 180. So if I do 89 plus 32, I get 121, and 180 minus 121 is 59. I look over here and say, well, there's no 59 here. Well, what's this angle right here? Again, I can do 63 plus 89, and I get 152, and 180 minus 152 is 28. And I look back and forth and say C and F have different angles, and A and D have different angles. So I don't have angle, angle, I just have angle. And so these are not similar. These are not similar because the corresponding angles are not congruent. Okay, in number 9, let's see here. Are the following triangles similar? Find the value of n and m. So looking at this, I'm first going to find n. N corresponds with 5. Now I'm probably going to use between figure ratios to figure this out. N divided by 5 is equal to. Now, I have to find the pair of numbers that correspond to each other where I know both numbers. In this case, 3.75 to 9.375. So I did a left to right or big to small before. And so again, I'll do 9.375 divided by 3.75. And even though the numbers don't look that nice with the big long decimals, I'll just keep going and cross multiply and hope for the best. So 5 times 9.375, 5 times 9.375 is 46.875, I'm not going to round off, is equal to 3.75 n. I'll divide both sides by 3.75. And I get n is 12.5. Now, is that logical? Yeah, it should be bigger than 5. I like to step back and make sure that it makes sense in the context of the problem. It isn't, too small or something. Okay, next I'm going to find m, which corresponds to 7.5. And I'll just keep it the same way before. So left over right or big over small is 7.5 over m. Okay, that will again have to correspond that with the ratio that I know. I'm doing left over right or big over small, which is 9.375 divided by 3.75. Okay, again, the numbers look a little messy, but I'll just cross multiply. 7.5 times 3.75, and I get 28.125. is equal to 9.375 m. Divide both sides by 9.375. 9.375. And m is equal to 9.375. M is 3. That worked out nice. And that's the length of m and n. Whoops, I did it again. Okay, last question. Mr. Robinson is 6 foot 1 inch tall, which is 73 inches, which you can find by multiplying 6 times 12 and then adding 1. Anyway, and at 3:30 p.m., his shadow is 38 inches long. Also at 3:30 p.m., he measures the shadow length of his house to be 131 inches long. How tall is his house? A, draw a diagram. Now, I'm going to draw a diagram, and Mr. Robinson will be super skinny in my picture, okay? So skinny that's Mr. Robinson, okay? He is 73 inches tall, okay? His shadow, now shadows don't happen in the air. Shadows happen on the ground, okay? When something is kind of blocked by the light. The ground is where the shadow is, which is 38 inches long, okay? I think about this as a triangle. Okay, that's Mr. Robinson. Now, if you want to kind of have a picture there too, you can. There's Mr. Robinson just standing there, being cool. Okay, now his house is also super skinny because he's super skinny, and his house is, let's just say it's here. And the shadow of his house, again, is on the ground, the same direction as Mr. Robinson. His house, I don't know how tall his house is, but the shadow length of his house is 131 inches. If you want a house, you can kind of draw a house. Anyway, that's my house. Not my house, it's Mr. Robinson's house. Now, that's the picture, right? I drew my dog. Okay. Identifies two similar triangles in the above diagram. Well, there's two triangles, especially if I kind of don't think about this part. I have two similar triangles. Explain why these triangles are similar. Well, we measure height perpendicular to the ground, right? And so based on that fact, I have one 90-degree angle in both triangles, and it's at the exact same time of the day. I'm assuming on the same day. And so the shadow angle is the exact same in both triangles. Okay, so these triangles are similar by angle. Okay, now, for the sake of space, I'm going to do C and D up here. C is asking you to use between figure ratios, okay, ratios that exist between the figures, in which case I will do X here corresponds to 73. This is between the two figures, not within a figure, but looking at corresponding sides between two figures. X over 73 is equal to, I'm doing a left over right, or in this case again, big over small, is equal to 131 divided by 38. Okay, if I cross multiply 73 times 131, and I get 9,563 is equal to, cross multiply this way, 38x, divide both sides by 38, and x is equal to 251.66 inches. Okay, now really that's not very helpful. I'm going to divide by 12, even though I don't have to, and find out this is 20.97 feet. Basically 21 feet tall is how tall his house is. All right, in D, it asks you to do the exact same problem, to answer the same question, but to use within figure ratios. Okay, within figure ratios is where you're looking within the figure, within the same figure, looking at a ratio there. Okay, in this case, I'll look at the height to shadow length ratio, which is 73 to 38. Okay, the height to shadow length. the corresponding ratio within the house picture is x over 131. Okay, if I cross multiply, 73 times 131 is again 9,563, which is equal to 38x. Okay, divide both sides by 38, and I get x again is 251.66 inches, which is 20.97 feet. You don't have to put down feet, but if you're someone asking you the question of how tall is my house, so you came back and said it's 251 inches, and they'll be like, how tall is it in feet? So I'm going to give it to them in feet anyway. So that's it. That is, I did it again. That is the entire review. All right, that's the end. Okay, so in this mid-module, we've talked about dilations, how to do dilations, looked at, we are verifying experimentally the properties of dilations, which is it being parallel and having a ratio with length the same as a scale factor. We've talked about using the side splitter theorem, okay, to find missing lengths. We talked about seeing if two figures are similar or not, using the definition of similarity, which is based on a sequence of similarity transformations. We've talked about more dilations, proving if triangles are similar or not using some similarity criteria, and then finding missing lengths in context and not in context. So hopefully that helps you prepare for the test. Thanks.